Hello. You have joined the U.S. Chemical Safety and Hazard Investigation Board's, or CSB's, public business meeting. We will now begin this meeting with Steve Owens, the chairperson of the CSB. Steve?
Well, thanks, Brian, and thank you all for joining us today. I'm Steve Owens. As Brian said, I'm the chairperson of the Chemical Safety Board. Welcome to the CSB's last regular public meeting of this fiscal year. Ordinarily, we'd be holding this meeting next month at the end of July, but because of various scheduling conflicts and other matters that have come up, we decided to move the meeting up to this month. But that said, we may have yet another public meeting before the end of this fiscal year, depending on the status of some of our ongoing investigations and other activities between now and then. We'll let you know if we decide to do that. And of course, we'll publish a notice in the Federal Register about it if we do it. For now, let me start, as I always do, by saying how incredibly busy we've been since our last public meeting last July. I'm sorry, in April, rather. Just last month, on May 28th, we issued the final report for the CSB's investigations into 3 catastrophic incidents at the Honeywell Performance Materials facility in Geismar, Louisiana. Each of these incidents involved the release of highly toxic hydrogen fluoride, and they all occurred within a 3-year period at the facility in October 2021, January 2023, and June 2024. Tragically, a worker died in the 2021 incident, and a worker was seriously injured in the 2024 incident. Fortunately, no one was killed or injured in the 2023 incident, but it involved a serious explosion that resulted in large amounts of HF and chlorine being released. And earlier this month, on June the 3rd, we issued the final report for the CSB's investigation into the fatal molten salt eruption at the TSUSA liquid nitriding facility in Chattanooga, Tennessee. That event occurred in May of last year. 1 employee was killed and 3 others were injured in the incident. The Honeywell and TSUSA reports are the 20th and 21st final investigative reports issued by the CSB since late July 2022, when the agency's new leadership took charge. These are the most reports ever issued by the CSB over a 3-year period, and they underscore the CSB's high level of productivity and efficiency during the last 3 years under the current board. These 21 reports cover a total of 23 incidents that involve 28 deaths, 108 serious injuries, and over $3 billion in damage to chemical facilities and to surrounding homes and businesses. We issued 155 safety recommendations as a result of these investigations. In addition to these new reports, we also recently issued updates on 2 of our current ongoing investigations. On May 26, we released the second update on the CSB's ongoing investigation into the major chemical fire that occurred last September at the biolab facility in Conyers, Georgia. The incident led to a massive plume of multicolored toxic smoke that resulted in 17,000 residents of the surrounding community being evacuated, and shelter-in-place orders were issued for roughly 90,000 people in the metropolitan Atlanta area. And just last week, on June 18th, we issued a second update on the fatal explosion of the Givaudan facility in Louisville, Kentucky, which occurred last November. 2 employees died in the incident, and several others were injured and taken to local hospitals. The blast also damaged a number of homes and businesses in the area. On top of all this, just a few weeks ago on May 22nd, we also released a new safety video. This was for the CSB's investigation into the December 2020 fatal explosion at the Optima Bell facility in Bell, West Virginia. An employee was killed in the incident, and the facility was extensively damaged. The Optima Bell video is the 3rd safety video released by the CSB since the beginning of this year, and that's the most safety videos that the CSB has ever issued in a 5-month span. You'll hear presentations about the Honeywell and TSUSA reports, as well as about the updates on the biolab and Givaudan investigations a little later in this meeting. We'll also show you the Optima Bell video. And with the Honeywell and TSU investigations now concluded, the CSB has 6 current investigations ongoing. The biolab and Givaudan investigations that I just mentioned are 2 of them. The 3rd investigation is the multiple explosions at the Dow Chemical facility in Plaquemine, Louisiana that occurred in July 2023 and resulted in the release of over 31,000 pounds of ethylene oxide a known carcinogen. The fourth investigation is a hazardous ammonia leak that occurred at the Cuisine Solutions food processing facility in Sterling, Virginia in July of last year. The release led to the hospitalization of dozens of workers, with some of them in serious condition. The fifth incident is the fatal release of hydrogen sulfide at the Pemex refinery in Deer Park, Texas, which occurred in October last year. 2 contract workers died as a result of the release. 35 people were injured and treated at the scene, and 13 others were transported to local medical facilities. Our 6th ongoing investigation is one that we just announced yesterday. We've launched an investigation into incidents involving toxic nitric acid at 2 facilities owned by the Austin Powder Company. One incident, which occurred 2 weeks ago on June 11, resulted in the release of hazardous nitrogen oxide gas at Austin Power's Red Diamond Explosives manufacturing facility in Benton County, Ohio. The other is a similar release that occurred last November at the U.S. Nitrogen facility in Greene County, Tennessee, which is owned by Austin Powder and which produces nitric acid that's used in products manufactured by Austin Powder. In both incidents, a large yellow brownish colored plume of hazardous nitrogen oxide gas covered each facility and much of the surrounding area. And in the recent Ohio incident, hundreds of nearby residents were evacuated. And according to local media, the Federal Aviation Administration temporarily restricted flights for a 30 nautical mile radius surrounding the facility. We initiated these investigations because we're concerned that incidents involving nitric acid have occurred at 2 facilities owned by Austin Powder, in less than 7 months. While fortunately no one was injured in either incident, we want to ensure that they do not continue to happen. Finally, on Monday of this week, we released a new video recapping some of the incidents recently investigated by the CSB. The CSB's released other videos like this periodically over the years, and we'd hoped to produce one a couple of years ago when we were celebrating the 25th anniversary of the CSB beginning operations. But we're a little too busy at the time working to eliminate the backlog, and since then we've continued to be very busy, issuing investigation reports, launching new investigations, and producing new safety videos, along with doing a whole lot of other things. But we managed to find a little time recently to put this short video together, and if time permits, we'll show it to you later on in this meeting as well. Before I turn the floor over to my fellow board members for their remarks, I want to remind everyone that at the end of today's presentations, we'll provide an opportunity for public comments. In the interest of time, we ask that you please keep your comments to 3 minutes, and please use the icon on your screen to raise your hand so that you can be recognized to speak. If you prefer to submit written comments, you can send them to public@csb.gov. That's public, P-U-B-L-I-C, at csb.gov. Now I'd like to turn this over to Board Member Sylvia Johnson for her remarks, and then to Board Member Kathy Sandoval. Sylvia, please go ahead, and then Kathy, please proceed when Sylvia's concluded. And thank you all again for being here.
Thank you, Steve, and thank you all for being here. Today's meeting is yet another reminder to us of what's at stake when chemical safety fails and what's possible when we get it right. As the chairperson said, since our last meeting, the CSB has completed major investigations and issued critical findings. Each one tells the same story: preventable hazards and communities left to carry the cost. As you heard from the chairperson, we've been quite busy, and you will hear updates on our recent reports shortly and see our newly released videos. So stay tuned for that. I would add that when safety takes a back seat, disaster takes the wheel, and the goal of the CSB continues to be to do all that we can to ensure that these incidents don't continue to happen. The mission of the CSB is one that doesn't wait. What we'll share today isn't just about failure and missed opportunities, it's yet another call to action. Every CSB investigation makes one thing undeniable: chemical incidents are preventable. With the right systems, training, and hazard management, these tragedies don't have to keep happening. I want to, as I usually do, I want to recognize the people making that possible, and that's the CSB staff. Your investigations are the foundation for lasting change. Progress doesn't happen by chance. It's the result of science, vigilance, and acting before disaster strikes. The work that you do matters. It protects lives, it strengthens public trust, and it helps companies turn the page from risk to responsibility. As we move forward, our mission stays firm to protect workers, communities, and the environment. Our story continues, and every action we take writes the next chapter. So thank you for your time and attention and commitment. And with that, I will turn it over to Kathy.
Thank you, Sylvia and Steve, and thanks to everybody for being here. As you've heard, excuse me, the CSB's work is critical to public and worker safety, protects the environment, and we make recommendations to ensure safe operation of chemical facilities. As highlighted in the CSB's recent safety video, which Chairman Owens mentioned, many chemical incidents have caused 1 million to nearly 1 billion in damage, with a staggering total of damage from chemical safety incidents. And these incidents are felt not just by chemical safety facilities, many of which are severely damaged or destroyed in these incidents, though they are part of the nation's critical infrastructure sector, the chemical sector. They also cause severe damage often to nearby homes, businesses, and to the environment. So it's important to underscore, as Dr. Johnson mentioned, that the CSB's work as a non-regulatory agency doesn't rely on findings of violations of any particular law, and we do not issue fines or penalties. Instead, based on the CSB's scientific and factual investigations, we make recommendations that can be implemented to prevent these incidents. And it's worth underscoring that many of these recommendations are made directly to business, to operators, as well as to standard-setting organizations, to a variety of federal, state, and local agencies, and others who can take steps to prevent chemical safety incidents. So you heard a little bit about recent CSB investigations, and we're going to discuss them in more detail in this meeting. And I wanted to highlight one thing that you'll hear about from the TSUSA investigation. One of the things that was important as a finding there is that it highlights that TSUSA's failure of knowledge management contributed to this incident. So knowledge management, as the term suggests, is about managing corporate knowledge, or I would also argue public knowledge. And one of the issues that happened was that TSUSA's corporate parent failed to disseminate information about other incidents that had happened at its plants around the world. And so the plant managers at different plants, including at TSUSA, were not able to learn from those incidents because knowledge had not been properly managed and disseminated. So the CSB, in many ways, provides this function of public knowledge management about chemical safety incidents. And its work in highlighting incidents, I also highlighting cross-cutting hazards, as we saw with the Martinez refinery incident, and then also with our recent incident and investigation report volumes, we highlighted the cross-cutting hazard of having workers stand next to fired up industrial heaters that have chemicals flowing through them, and having workers stand next to them during their operations is incredibly hazardous and has put people in harm's way that have resulted in deaths and serious harms. So these incident reports, as well as our investigation, have been important tools for highlighting cross-cutting hazards that then others can investigate and address. So would like to also join with Sylvia and Chairman Owens in thanking everyone at the CSB and the whole CSB staff for their important work. I'd like to thank the communities who've hosted the CSB's investigations, and thanks to everyone for supporting this work. The CSB's work really is highlighting these issues, But ultimately, it is up to all of you to make sure that these recommendations are implemented so that we can keep our community safe and help keep this critical sector operating safely and for the benefit of our communities and our nation. Thank you.
Thank you, Sylvia, and thank you, Kathy, for those remarks. Now we'll turn it over to our Executive Director of Investigations and Recommendations, Steve Kleist, for a presentation on the investigation reports that I mentioned, as well as the updates.
Thank you, Chairperson Owens. This afternoon, we are going to present 6 presentations that highlight the work of the Office of Investigations and Recommendations staff that have been produced since the last public meeting that we had in April of this year. The first presentation will be on the Honeywell accidental release event that took place in Geismar, Louisiana. The investigator in charge, Drew Solly, will lead the presentation, and he will be assisted by chemical incident investigator Donald Nixon, who was part of the investigation team. So, Mr. Solly, please proceed.
Thank you, Executive Director Kleist. Good afternoon, everyone. My name is Drew Solly, and I was the investigator in charge of the Honeywell Geismar investigations. Along with me today is my teammate, Don Nixon. Today, we're going to provide a summary of the investigation report, which was published in May. The final investigation report covers 3 separate hydrogen fluoride, or HF, incidents, all 3 of which occurred in the same unit at the Honeywell facility in Geismar, Louisiana. I'll be covering the first 2 incidents discussed in the report, and Don is going to cover the third incident, along with the common factors associated with all 3. As I stated earlier, all 3 of these incidents occurred in the same unit at the Geismar site, and the company refers to this unit as the 245 unit. The first incident occurred on October 21st, 2021. Honeywell was attempting to start up a reactor in its 245 unit. The startup attempt involved charging a heat exchanger called the vaporizer with HF from the site's HF manufacturing unit. During this startup attempt, the board operator was unable to achieve flow to the HF vaporizer. He dispatched a field operator to troubleshoot the issue. While the field operator was attempting to resolve this no-flow condition, he smelled a nearby leak of HF and turned and saw HF vapor leaking from a nearby flanged piping connection. He stopped troubleshooting efforts on the no-flow condition and summoned another field operator to the area to help him resolve the leaking flanged connection. Assuming that the HF was leaking from the upstream direction, the first field operator went to close an upstream valve, believing that that might stop the source of the leaking HF. But unknown to either operator, the HF was actually backflowing from the downstream direction. While the first operator was closing the upstream valve, the second field operator remained near the leaking flange. Suddenly, the gasket inside the flange connection catastrophically failed, and the second field operator was sprayed with HF liquid and vapor on his face, ear, and neck. He was not wearing PPE sufficient to protect him from HF and died in the hospital later that day. The first field operator was unharmed. In total, 39 pounds of HF were released during this incident, and Honeywell reported $14 million in property damage resulting from the release. The CSB identified 3 safety issues for this incident. Those are technology change implementation, mechanical integrity, and safe work practices. The first issue is technology change implementation. The 245 unit began operations in 2002. Within the first 5 years of the unit's operation, Honeywell documented corrosion failures to spiral wound gaskets in certain HF services within the unit. Honeywell identified a new gasket technology and conducted a management of change review. During the MOC process, Honeywell made the decision to replace the corroding gaskets by attrition. This was because the company believed that the existing gaskets were still acceptable for the service, despite the gaskets experiencing ongoing corrosion since the unit first began operating. 14 years later, in 2021, one of these spiral wound gaskets failed catastrophically and fatally injured a Honeywell operator. The second issue is mechanical integrity. Honeywell had a mechanical integrity inspection program for the piping involved in the incident. And in the 36 days prior to the incident, Honeywell inspected the incident piping twice, once as part of this MI program and once as part of its leak detection and repair, or LDAR program. Neither inspection identified any problems with the incident piping. Additionally, Honeywell did not use technologies that could have helped its inspectors and operators identify the leaking gasket prior to its catastrophic failure. These technologies include acid indicating paint and remote HF monitors. These technologies are either required or strongly suggested by industry guidance from the API and HF industry trade groups. Further, the use of these technologies is heavily recommended by Honeywell itself. Honeywell operates a business unit in which it sells HF safety-related services and products. That business unit recommends to its customers to use acid indicating paint and HF monitoring. But despite Honeywell's own guidance to its customers, Honeywell was not using the technology in its own 245 unit. The third safety issue for the 2021 incident is safe work practices. Honeywell attempted to start up equipment that was not ready for operation, and its startup attempt did not follow the company's written startup procedures. Because the startup procedures were not followed, the valve on the HF inlet to the vaporizer was left closed after a planned maintenance outage, but the valve was never reopened prior to the startup attempt. This caused the no-flow condition to the vaporizer, which in turn caused the presence of the two field operators in the vicinity of the leaking incident gasket. Also, neither of the two field operators were wearing adequately protective PPE during the incident, resulting in one of the operators' fatal exposure to HF. Finally, during the emergency response, Honeywell's emergency response team wore PPE that was less protective than what was required by Honeywell emergency response procedures. I'll now cover the second incident, the 2023 catastrophic reboiler explosion. The second incident occurred on January 23, 2023. Honeywell was starting up the 245 unit after an unplanned outage. The startup proceeded normally until the reboiler suddenly and catastrophically exploded. The reboiler failed at normal operating conditions that were within the reboiler's as-designed temperature and pressure limits. Over 800 pounds of anhydrous HF and over 1,600 pounds of chlorine were released during this incident, and the explosion met the definition of a BLEVE, or a boiling liquid expanding vapor explosion. Honeywell reported $4 million in property damage, and there were no injuries associated with the incident, very fortunately. The CSB identified 4 safety issues for this incident. Those are mechanical integrity, the management of organizational and personnel change, capital project management, and organizational resilience. First, I'll cover MI. Since the reboiler's original installation, Honeywell Geismar has run it to failure 4 times. The failures occurred in 2003, 2008, 2012, and 2023. Honeywell had a pressure vessel inspection program and generally followed the guidance in API 510. Additionally, the reboiler's carbon steel shell corroded at rates that were consistent with published industry data, data which Honeywell was aware of. Despite this, Honeywell's mechanical integrity program was unable to prevent any of the 4 shell failures. The incident shell was installed in 2012. Prior to the 2023 explosion, Honeywell last inspected the shell in October of 2021, about 15 months prior to the explosion. Honeywell detected that the shell was approaching its minimum thickness and initiated a capital project to replace the shell. Management approved the project in February 2022, but the project was never completed, and Honeywell never purchased or installed a replacement shell prior to the explosion. The next safety issue is the management of organizational and personnel change. After the Geismar Site Reliability Organization inspected the reboiler in October 2021 and detected the shell thinning, the reliability team referred the reboiler to the 245 unit's maintenance engineer. The maintenance engineer initiated a capital expenditure request or project in January 2022, and site management approved it in February 2022. Subsequently, in April of that year, the 245 unit maintenance engineer left the company for employment elsewhere. The CSB determined during its investigation that this single engineer was the only employee at the Geismar site who had active current knowledge of the reboiler project when he departed the site. Honeywell had an existing applicable management system for managing personnel change, but when the 245 unit maintenance engineer left the company, his manager never performed an MOOC analysis and never reassigned the reboiler project to another employee. As a result, the project went unmanaged and the reboiler ran to failure in January 2023. Honeywell also did not apply its MOOC policy and procedure to several other significant changes at the site, including a large-scale reduction in force, ongoing vacancies to 2 key site management positions, and other personnel changes. The third safety issue for the second incident is Honeywell's management of capital projects. Honeywell had 2 primary ways that it handled capital projects. First, it prioritized projects according to their criticality and complexity. Generally, less complex, less expensive projects, like the one to replace the reboiler shell, were supposed to be funded almost immediately after being approved by management. The reboiler project was approved by management in February of 22, but it ultimately never received funding. From October 2021 to January of 2023, Honeywell approved 142 projects for capital funding. Of these 142, 78 were either unprioritized at all or were prioritized lower than the reboiler project. Despite this, Honeywell funded all 78 of these projects instead of the reboiler project. As a result, the reboiler ultimately ran to failure. This indicates that Honeywell's capital project management system was operating outside of its procedural and policy requirements. Finally, the last safety topic for the reboiler failure is organizational resilience. As a concept, organizational resilience is defined as an organization's ability to detect, cope, and adapt to changes and disruptions to normal operation. In October 2021, Honeywell Geismar experienced a fatality incident, which I described earlier. After that incident, Honeywell diverted the site's attention and resources to resolving the causes of that incident. But while the company was focusing on the 2021 incident, other management systems at the site were failing to perform as intended. Honeywell did not detect these management system failures and did not resolve the conditions that ultimately led to the reboiler explosion. Essentially, one catastrophic incident at the site may have led to another. That completes my review of the 2021 and 2023 incidents. Next, I'll pass the baton on to my teammate, Don Nixon.
Thank you, Drew. I will talk about the third incident, common factors, and some recommendations. Next slide, please. Leading up to the incident, the 245 unit was undergoing a planned maintenance outage. A few days before the incident, Honeywell prepared the D-reactor fresh feed station for maintenance, including locking out the piping segment. On the morning of the incident, 2 Turner pipe fitters obtained permits from a Honeywell operator to conduct gasket change work. The 2 Turner workers and the Honeywell operator proceeded to the unit to review the job and conduct a line break. The 2 Turner workers donned level B PPE, which included acid-resistant suits and supplied fresh air. The Honeywell operator wore level D PPE. At the Honeywell operator's direction, the Turner worker opened the fresh HF feed station piping in 4 locations to monitor the piping for any signs of residual HF. The operator observed no HF and believed that the piping was sufficiently clear. He then closed out the line break permit, and the 2 Turner workers conducted the rest of the job under a safe work permit, which required only level D PPE. As the 2 workers proceeded through the work, one of them loosened the blind flange on one of the 2 bleed valves. Neither the Turner workers nor the Honeywell operator were aware that the valve had not been cleared of HF prior to the work. Less than 1 pound of HF was trapped between the valve plug and the blind flange. When one of the Turner workers loosened the blind flange fasteners, the trapped HF was released. The Turner worker was not wearing face or respiratory protection, and the released HF contacted him in the face, causing serious injuries. The worker was treated with nebulized calcium gluconate and was transported to a local hospital, where he was admitted and spent 2 days recovering as a result of his serious injury. He sustained 2nd-degree burns from the HF exposure. Next slide, please. The CSB identified one main safety issue: safe work practices. The blind flange connection from which the HF was released was not within the job scope. Yet, from a safety perspective, whether the flange was in or out of the job is not relevant, because the valve was within the bounds of the locked out piping and should have been cleared of hazardous energy. Honeywell did not clear the valve during its preparation for maintenance. Further, immediately prior to and during the work, neither Honeywell nor the contract workers identified the hazard. Because the valve was in the closed position, there was no way for them to be sure that the valve had been cleared during maintenance preparation. After conducting initial line breaking activities in level B PPE, Honeywell and Turner closed out the line break permit, and the two Turner workers removed their level B PPE because they believed the piping segment was free of hazardous energy. Had the Turner workers been wearing sufficiently protective PPE, his injury would have been prevented. Next slide, please. I'll discuss common factors and pertinent regulations. All three incidents resulted from the ineffective implementation of Honeywell's existing safety management systems. Had Honeywell followed its normal procedures, policies, and practices, it could have and likely would have prevented each of the three incidents. Next slide, please. Both the EPA rule and the OSHA PSM standard require facilities to self-assess their process safety management systems by performing compliance audits every 3 years. Honeywell International's policy required process safety audits every 3 years for covered sites, which included the Geisinger site. The Geisinger site was audited in 2014, 2017, 2020, and 2023. Honeywell identified findings and implemented corrective actions as a result of those audits, but none of the previous audits identified or effectively addressed the problems that led to the three incidents discussed in this report. In 2024, the EPA revised its RMP regulations. Among the changes, EPA now requires chemical facilities that have had a prior incident to undergo third-party compliance audits instead of self-audits. Although it is a regulatory requirement for Honeywell to conduct a third-party audit, Honeywell's next audit is not due to occur until 2026. In addition, the RMP regulations do not cover all of the management systems that the CSB identified as causal factors to the three incidents that occurred in 2021, 2023, and 2024, such as the management of organizational personnel change, the management of safety critical capital projects, and organizational resilience. Next slide, please. In addition to auditing, the Toxic Substances Control Act, or TSCA, requires that the EPA evaluate and prioritize chemical substances for regulation under TSCA. HF is a highly toxic chemical that can produce a vapor cloud upon release. HF is one of the 8 most hazardous chemicals regulated by the RMP rule. Next slide, please. As a result of its investigation, the CSB issued recommendations to Honeywell International, the EPA, and OSHA. Next slide. CSB's recommendations for Honeywell International include performing a third-party audit of the Geisinger site's process safety and allied management systems. Honeywell should require periodic reporting updates from the Geisinger site regarding the closure of the audit findings. Honeywell should also perform a safer technologies and alternatives analysis, or also known as STA, for the Honeywell Geisinger HFC 245 FA unit. Honeywell should follow the language in the EPA's RMP rule promulgated in May of 2024. For the US EPA, CSB recommends that EPA initiate its TSCA prioritization process for HF. and for the EPA to take appropriate subsequent actions depending on the results of the classification process. For the Occupational Safety and Health Administration, the CSB reiterates a recommendation from the 2005 BP Texas City investigation. OSHA should amend the PSM standard to require the management of organizational and personnel change. This concludes the CSB's presentation of the Honeywell-Geisler investigation report. Thank you. Executive Director Kleist, back to you.
Thank you, Don, and thank you, Drew, for the presentation on the Honeywell series of incidents. The next presentation will focus on the CSB's investigation of the TSUSA liquid nitriding facility in Chattanooga, Tennessee. The presentation will be made by the investigator in charge, Cruz Redmond, and supplemented by chemical engineer Owen Tripeny. Cruz, please begin the presentation.
Thank you, Executive Director Kleist. Good afternoon. My name is Cruz Redmond, and I was the investigator in charge of the CSB's investigation into the explosion, molten salt eruption, and fatal injury that occurred on May 30th, 2024 at the TSUSA facility in Chattanooga, Tennessee. I, along with investigator Owen Tripeny, will be providing a summary of the details of this investigation that was published earlier this month. TSUSA is a subsidiary company of HEF Group, which is an international company headquartered in France. TSUSA operates multiple facilities where it performs different treatments to harden and improve the wear resistance of metal parts. At the Chattanooga facility, TSUSA performed liquid nitriding to treat metal parts, providing increased wear and corrosion resistance. The liquid nitriding process, which can be seen in the schematic, is a process where metal parts are submerged in a series of water and molten salt baths by an overhead crane. These molten salts are greater than 800 degrees Fahrenheit. On May 24th, 2024, TSUSA began treating 5 rollers, seen in the picture at the bottom, through the liquid nitriding process. These rollers were large cylindrical metal parts that had an internal cavity. The rollers were approximately 8 feet long and 5 inches in outer diameter and had press fit ends. The internal cavities were approximately 7 feet long and had an inner diameter of 4 inches. The rollers also had 5mm drain holes at the top and bottom. By the evening of May 29th, the rollers were processed completely through the nitriding and reoxidation processes and were left in the hot water rinse bath overnight. On the morning of May 30th, the rollers were removed from the water bath to allow them to drain and cool. However, after 1 hour of cooling and draining, TSUSA employees found that one of the rollers remained too hot to continuously touch. They also observed salt obstructing the bottom drain hole and believed that salt had solidified inside the roller cavity. The TSUSA employees contacted the process engineer, who worked remotely from the site, to develop a path forward to address the roller that was still too hot. A plan was developed to reintroduce these rollers to the oxidizer bath to melt the solidified salt flow. This plan was then communicated to the line operator. At 8:51 a.m., the line operator moved the rollers with the overhead crane and partially submerged the rollers in the oxidizer bath. At 8:58 a.m., an explosion occurred and the oxidizing salt erupted from the molten salt bath, which you can see in the picture to the left. The released molten salt engulfed the line operator, causing thermal and chemical burns, which fatally injured him. The CSB determined that the cause of the incident was the introduction of water contained in the roller cavity to the 800-degree Fahrenheit oxidizing salt bath. The hot salt caused the water to expand and boil in the cavity of a roller, which resulted in an overpressure, steam explosion, and a molten salt eruption. During the normal treatment process, the rollers were submerged in the oxidizer bath. When they were submerged, the molten salts enter the roller cavities. They were then raised to allow the salt to drain. However, the salt did not fully drain from one of the rollers and solidified at the bottom. The rollers were then submerged in a hot water bath to rinse and dissolve residual salt. Due to the solidified plug of salt in the bottom of one of the rollers, the water that entered the cavity could not drain when the parts were removed from the water bath. This hot water in the cavity resulted in the roller being too hot to continuously touch when the TSUSA employees were examining the parts on the morning of the incident. When the rollers were reintroduced to the molten salt bath, the water in the roller cavity began to boil, which increased its internal pressure. Ultimately, the increasing pressure caused the press fit end of the roller to dislodge and launch the roller from the salt bath. Additionally, the water and steam contacted the molten salt and caused a steam explosion. This explosion and the rapid generation of steam displaced the molten salt, resulting in the eruption from the oxidizer. You can see that in the schematic to the right. Now I will hand it over to Owen to discuss and provide an overview of the safety issues and recommendations.
Thank you, Cruz. The CSB identified 3 safety issues during its investigation into the explosion and molten salt eruption at TSUSA: safety management systems, learning from past incidents, and corporate engagement. The first issue identified was safety management systems. While TSUSA had established a quality management system to ensure that parts met the appropriate quality standards, the company did not have an adequate process safety management system in place. As a result, there were insufficient programs at the Chattanooga facility to ensure the safety of the employees and equipment. TSUSA did not have procedures for reprocessing parts in the oxidizing bath, and the existing procedures for normal operation were inadequate. Additionally, TSUSA did not train its employees on the hazards associated with the nitriding line. Finally, TSUSA lacked hazard analyses for accepting and processing new parts, reprocessing parts, and the operation of the liquid nitriding line. Due to the lack of an adequate safety management system, TSUSA employees were unprotected from and unaware that the hazards presented by the nitriding line, the potential for part cavities to entrap materials, and reprocessing the rollers. The second safety issue identified during the investigation was learning from past incidents. Before the incident at Chattanooga in 2024, the CSB identified 3 other events that occurred due to the entrapment of materials and parts. The first explosion occurred in 2018 at an HEF facility in Mexico. Water was trapped in a part with an internal cavity. The water boiled and overpressured the part when it was submerged in the nitriding salt bath. The second explosion occurred in 2020 at an HEF facility in France. A part with a welded seal cavity and trapped air. When the part was submerged in the nitriding salt bath, the air increased in pressure and overpressured the seal cavity, causing an explosion that ejected salt. The last event occurred at the Chattanooga facility in 2023, less than 1 year before the 2024 incident. Nitriding salts were trapped in the cavity of a part and were carried over to the oxidizing bath. The salts reacted, causing the oxidizing salts to overflow from the molten salt bath. TSUSA and HEF Group did not adequately investigate these incidents, perform causal analysis, develop corrective actions, or generate formal investigation reports. Additionally, HEF Group did not ensure the events were communicated to other facilities within the organization. The last safety issue identified during the investigation was corporate engagement, which has 2 components: knowledge management and corporate governance. While HEF Group developed safety information such as hazard analyses, it did not provide the knowledge to its subsidiary facilities. All of the safety information was centralized at the corporate level, and HEF relied on corporate meetings and safety letters to share the information throughout the company. It did not ensure that all of its employees had access to the information. Additionally, while HEF Group did perform risk assessments on the liquid nitriding line, the findings were not communicated to its subsidiaries, and the assessments only existed in French. As previously discussed, HEF Group also did not ensure that incidents and corrective actions were communicated to its other sites. HEF Group also had insufficient governance of their subsidiary facilities. It did not ensure that other sites were following the company's safety guidance, such as the risk assessments. Finally, HEF Group did not provide adequate resources, such as safety personnel, to ensure that safety guidelines were implemented and followed at all locations. The CSB made recommendations to two entities, TSUSA and HEF Group. The CSB made three recommendations to TSUSA. First, the CSB recommended that TSUSA implement physical protective barriers around the molten salt baths to isolate employees from hazardous releases at all of its liquid nitrating facilities. Second, the CSB recommended that TSUSA develop a safety management system that includes programs for hazard analyses, written operation procedures, training, and incident investigation. Lastly, the CSB recommended that TSUSA establish a position at each of its facilities that is responsible for the new safety management system and ensuring that HEF guidelines, regulatory requirements, and industry safety guidelines were followed. The CSB made four recommendations to HEF Group. First, the CSB recommended that HEF Group implement physical protective barriers around the molten salt baths to isolate employees from hazardous releases as part of its design for liquid nitrating facilities. Second, the CSB recommended that HEF Group develop a safety management system like the one the CSB recommended to TSUSA. Third, the CSB recommended that HEF Group establish a comprehensive knowledge management program for sharing information through the HEF Group organization. This program shall include knowledge from audits, hazard analyses, and incident investigations, including causal analysis and corrective actions. Finally, the CSB recommended that HEF Group establish a corporate governance program. This program shall include regular audits of facilities with tracking and accountability for the implementation of all corrective actions identified by the audit. The audits shall also evaluate facility adherence to the recommended safety management system. The corporate government program shall also require documentation of all audit findings, prompt response to deficiencies, development of corrective actions, and the implementation of the corrective actions throughout the organization. This concludes the CSB's presentation on the TSUSA investigation. I will now turn it back over to Executive Director Kleist.
Well, thank you, Cruz and Owen, for that presentation. And while there were many investigators that supported both the Honeywell investigation and the TSUSA investigations, I thank you all for your contribution from deployment through report development through completion of the report. I would like to recognize one person in particular this afternoon, Owen Tripany. And this is Owen's first full investigation since he completed the agency's Pathways program as a chemical engineer. So I do want to recognize Owen for his superior work, along with all the individuals at the agency that mentored him through this process that gave us the result that we have today. So congratulations to Owen. Our next presentation will be on the second investigation update that the agency published in connection with the biolab facility in Conyers, Georgia. The investigator in charge, Vanzella Vincent, will be making the presentation this afternoon. Vanzella, please proceed.
Thank you, Executive Director Kleist. Good afternoon. I am Vanzella Vincent, and I will be presenting an update to the biolab investigation on behalf of our team. First, let's review some background information regarding biolab. The biolab Conyers facility has been in operation since 1973 in Rockdale County, located in Conyers, Georgia. The Conyers site converts raw materials and packages finished recreational water care consumer products for retail sale. One of the chemical storage warehouses at the Conyers facility was involved in the incident on September 29, 2024. At the time of the incident, biolab was storing approximately 13.9 million pounds of reactive chemicals, which was more than double the amount reported to Rockdale County as its anticipated average inventory for its commercial permit application purposes. According to the biolab, the chemical storage warehouse stored large flexible bulk bags, as shown in the photo, containing multiple solids which have a chlorine odor, such as trichloroisomeric acid, also known as TCCA, including the 99% TCCA that's manufactured by Biolab and various formulations of TCCA. Also, anhydrous sodium dichloroisomeric, sodium dichloroisomeric dihydrate, and bromine, also known as BCDMH. These chemicals are classified as oxidizers by the National Fire Protection Association, or NFPA, and they can release toxic and corrosive byproducts when they decompose. When wet, TCCA and sodium dichloroisomeric may produce nitrogen, trichloride, and explosion hazard. Additionally, they have water reactive characteristics according to the NFPA's definition of a water reactive material. Biolab experienced frequent failures related to corroding components of the building's fire protection system safeguards. A firewall intended to prevent the spread of a fire divided the warehouse into two storage areas. The area behind the firewall was referred to as the bunker. In 2019, a fire and risk consultant determined that the automatic early suppression fast response sprinkler system at a minimum design pressure of 52 pounds per square inch was adequate for Biolab's plan to store large nylon flexible bags containing the Class 1 oxidizer TCCA stacked too high inside the bunker using floor storage. In 2021, after the warehouse had been built and used for storing chemicals, Biolab added rack storage. In 2024, according to the inventory documentation provided, nearly 2.9 million pounds of TCCA, sodium dichloride, both in anhydrous and dihydrate form, were stored outside the bunker near the firewall and along other dry chemicals within the rack storage system. Leading up to the incident, Biolab had also experienced multiple sprinkler system failures in the warehouse due to corrosion. Biolab ceased all on-site operations on September 26, after Governor Kemp declared a state of emergency in preparation for Hurricane Helene. Approximately 10 inches of rain fell in Conyers between September 26th and 27th from the hurricane. Biolab personnel on site the night of the storm shared that roof leaks were controlled by and captured with buckets. It was also reported that at the time of the heaviest rainfall, it took a little while for water just to cover the bottom of the bucket. There was no rainfall in the 24 hours before the incident. Now I will give you an overview of the incident. On September 29th, 2024, at approximately 5:00 a.m., a chemical reaction occurred inside the warehouse involving the bulk solid materials that were stored inside. This reaction resulted in product decomposition, the generation of excessive heat, multiple fires, excessive off-gassing, and the release of toxic vapors. The community was put at risk of being exposed to toxic chlorine gas. Shelter-in-place orders were issued and mandatory evacuations. The final shelter-in-place warning within a 2-mile radius expired several weeks after the incident on October 17th. Interstate I-20 was closed for approximately 19 hours and other small roads closed longer. Smog or haze with a chlorine smell drifted in parts of the metropolitan area. The EPA and commissioned subcontractors conducted air monitoring at the biolab facility and surrounding areas. The warehouse was completely destroyed. No injuries were reported at the site during the incident or in the subsequent emergency response that followed. 2 biolab employees were on site at the start of the reaction. One of them heard the initial popping sound, which was likely from the nitrogen trichloride produced when the TCCA and/or sodium dichloride got wet, and called the other employee, who was an ERT member. Rockdale County Fire and Rescue and additional biolab personnel arrived on site within 30 minutes of the event discovery. A large volume of water was observed flowing out of the warehouse when responders entered the building for reconnaissance. At approximately 6:30 a.m., flames were visible on the roof above the area where the reaction and off-gassing were initially observed. The first small fire, which was a roof membrane fire, was extinguished around 8:10 a.m. At approximately 9:40 a.m., witnesses observed a large volume of water still flowing from the building. Around noon, a second larger fire erupted, which produced thick black smoke, followed by multicolored plumes of smoke. The roof and most of the walls had collapsed by 8:00 p.m., trapping some chemicals underneath. Excavation equipment was used to allow emergency response personnel access to extinguish fire hotspots and reacting product. Post-incident, a controlled demolition of the warehouse under a unified command was established to remove the remaining chemicals and structural components. Biolab managed the collection, sampling, and disposal of surface water runoff at the site during cleanup and remediation activities. In May 2025, Biolab announced it had completed remediation of the site affected by the incident. In September 2025, the Biolab decided to not restart manufacturing at the Conyers plant. Path forward for the CSB team. The investigation team is continuing to gather facts and analyze key areas of the biolab incident, including testing some of the chemicals stored in the warehouse at the time of the incident to quantify their water reactivity characteristics, information and evidence to help determine the most likely water source that initiated the chemical reaction in the morning, storage and handling of oxidizers and their compatibility, which also have water reactive characteristics, and regulatory and industry guidance on storage and handling of reactive materials, including fire protection systems. Complete findings, analyses, recommendations, if appropriate, and key lessons will be detailed in the final investigation report. This concludes the update of the biolab investigation. I now turn the presentation back to Executive Director Kleiss.
Gonzalo, thank you very much for the comprehensive update on the Biolab Conyers, Georgia incident. The next presentation will be on the CSB's second investigation update on the Givaudan Sense Color accidental release event that took place in Louisville, Kentucky. Supervisory chemical supervisor Mark Wingard will be making the presentation today. Mark, please proceed.
Thank you, Executive Director Kleist. As Director Kleist said, my name is Mark Wingard, and today I'm going to be giving you an update on our investigation into the Givaudan incident. Next slide, please. On November 12th, 2024, a batch reactor producing caramel coloring exploded at the Givaudan facility in Louisville, Kentucky. The explosion fatally injured 2 Givaudan employees and seriously injured 3 other employees. The event ejected vessel fragments and various building materials into nearby residential neighborhoods. The explosion damaged nearby homes and businesses and caused substantial damage to the Givaudan facility. On the day of the incident, the reactor's materials included invert, which was composed of a sugar ingredient, water, sodium hydroxide, phosphoric acid, and an anti-foam additive. Next slide, please. Uncontrolled runaway reactions have led to many catastrophic explosions. The Givaudan incident exhibited similarities to other runaway reaction disasters that the CSB has investigated. This event involved the use of a batch production process. The reactor experienced a rapid and uncontrolled rise in temperature and pressure, culminating in an explosion that caused great harm. The CSB conducted laboratory reactivity tests to determine whether the materials in the batch reactor could produce such a runaway reaction. These tests evaluated Givaudan's reactor materials for potential reactions that generate heat or produce gaseous byproducts. Testing was completed for the batch reactor mixture used on the day of the incident, as well as for the sugar ingredient alone. Next slide, please. The testing determined that the batch reactor materials behaved similarly to the sugar ingredient. The tests found that the materials decomposed with self-heating that started within the reactor's normal operating limits. The reaction produced carbon dioxide, a non-condensable gas. These graphs provided show that the decompositions generated high temperatures and pressures. Overall, the testing showed that the Givaudan's reactor materials can undergo a runaway reaction, which is capable of causing an explosion similar to the one on the day of the incident. Next slide, please. The CSB investigation is ongoing, and the CSB is continuing to gather facts and analyze several key areas, including conducting additional chemical testing, analyzing equipment recovered from the site, and evaluating the batch reactor's pressure relief system design. Thank you. That's all for the update on Givaudan. I'll now turn it back to Executive Director Kleist.
Mark, thank you for the update. The next presentation will focus on activity in the Office of Recommendations. Director of Recommendations Chuck Barbie and Recommendations Specialist Adam Henson will be making the presentation this afternoon. Chuck, please proceed.
Thank you, Executive Director Kleist. So what we're going to talk about today, initially, hold on. Interesting. Okay. Anyway, we're going to talk about today initially is stakeholder engagement. Stakeholder engagement is actually very, very critical in implementing recommendations. And then we're going to go into the highlighted recommendations for this particular quarter. One of the reasons that stakeholder engagement, so all of us in the Office of Recommendations are involved in stakeholder engagement. However, one of the reasons that Adam Henson is providing this particular presentation is because he is our resident expert. He goes out and he personally engages with these groups, and he gets great results as a result of that. So without any further ado, I will go ahead and pass it on to Adam Henson.
Thank you, Chuck. Next slide, please. The CSB strategic goal 2 is to advance safety and enact change through recommendations, outreach, and education. As you can imagine, we can't accomplish that ourselves alone in a vacuum. So as Chuck said, we have to go out, we have to engage with our stakeholders. Today I'm happy to be here to talk to you today about some of those engagement activities with some of our larger stakeholders who are the standards development organizations listed on the screen there. Next slide, please. The American Petroleum Institute is by and away the largest stakeholder that we have based solely on the number of recommendations that they've received. They've received more recommendations than anyone else, and that is partly due to the fact that the subject matters that they covered are so inextricably linked to what it is that we do, and also because of the industry's recognition of them as a developer of codes and safety standards. Recently, we have attended the API's fall and spring refinery equipment and standards meetings, during which time we have engaged with their subcommittees on inspection and mechanical integrity, above ground storage tanks, instrumentation and control systems, heat transfer equipment, and not to forget anybody, we have also engaged with their. Actually, that was everybody. Thank you. We've had a lot of success. Oh, back, please, if you could go back. We've actually had a lot of success working with API in the last several years, having closed 12 recommendations. Based off the activities we've done recently, we've actually managed to avoid, or we've advanced 3 of the recommendations to a status of open acceptable response. And we hope to work cooperatively with them in the future to close the remaining recommendations, of which there are about 15. Another opportunity granted to us for stakeholder engagement by the API was they allowed us to give presentations at their Operating Practices Symposium during both events, which is co-sponsored by the American Fuel and Petrochemical Manufacturers. During the one in fall, we discussed the lessons learned from BP Husky, Oregon, and during the one in springtime, Malika Yerzi's discussed the lessons learned from Marathon Petroleum in California. We truly appreciate the opportunities that they've afforded us to meet with industry. Next slide, please. The NFPA, while having received substantially fewer recommendations, has always been a very cooperative partner in advancing safety in industry. Most recently, we have successfully worked with the NFPA standards committees on combustible dust to assist in the publication of NFPA 660, which contained information in it relative to our recommendation from the Didion milling explosion. That recommendation was closed, exceeded recommended action, in recognition of the tremendous value that that document will bring to safety in the combustible dust handling industries. Just last month, we sat down with the NFPA's Committee with Industrial and Medical Gases to discuss our recommendation from the FFG investigation. During that meeting, substantial improvements in the code NFPA 55 were made as it pertains to cryogenic freezing equipment. In addition to the cryogenic freezing equipment, liquid nitrogen, the NFPA has also added language to their standard which covers carbon dioxide freezing equipment, which poses nearly identical hazards. The only remaining recommendation that the NFPA has left to address with the CSB is from the Wacker polysilicon incident. We put in public inputs to NFPA 400, the Hazardous Materials Code, and we look forward to engaging with that committee in the time to come. Finally, they have afforded us the opportunity to present at their national conference in both 2023, where we talked about combustible dust, and also in 2024, where we discussed inherently safer design. Both presentations were attended by nearly 100 participants and were very well received. Next slide, please. For those unfamiliar, the International Code Council has a very, very intricate standards development process that's comprised of more meetings than I can count on all hands and toes. And it has just been a pleasure to work with them on their 4 open recommendations, as well as 2 recommendations that were closed on acceptable action that, based off code changes that have been accepted by the committee, will hopefully be able to change to a close of acceptable status, or at least an alternative acceptable status. Next slide, please. And then coming up to the end of it here, I'd like to discuss the National Board of Boiler and Pressure Vessel Inspectors. This stakeholder group, or this particular organization has only ever received 2 recommendations from the CSB, only one of which you could really consider to be substantive, and that was from our Loy Lang investigation. That recommendation asked the NBBI to update their rules for commissioned inspectors to address facets of the incident. Not only did they do that, but they also engaged the CSB in their standards development process for the National Board Inspection Code, leading to substantially improved requirements as it pertains to the incident that happened at Loy Lang. They also wrote a multi-page cover story article in their magazine, the NBBI Bulletin, specifically on Loy Lang. They published an article that we wrote on pressure vessel safety incidents in general in a later version of that magazine, and they gave us the opportunity to present at their national meeting. Next slide, please. And then finally, there is the International Society for Automation. This group has only ever received 1 recommendation from the CSB, and it was from our BP Husky, Oregon case. We asked them to come up with a series of metrics to determine the severity and the severity of what's called alarm flood. And then they have done is they've go ahead and they've They've made a task group to go ahead and address the recommendation, but they've even taken it just another step further. They're not only just going to help people to count alarm floods and determine how severe they were, they're also working on procedures that can be enacted in the moment to either terminate the alarm flood itself or at the very least to mitigate its consequences. Their response has been tremendous. The group is very well attended and very active and engaged. We really look forward to seeing what they come out with sometime in 2026 when the next version of ISA 18.2 is published. This concludes my discussion of our engagement with our stakeholders recently. Back to you, Director Barbie.
Thank you very much, Adam. So now I get the opportunity to go over some of the recommendations that we closed this quarter. And as always, I like the opportunity to talk about the prior trust investigation. It is one of my favorites. I have to say, Supervisory Chemical Incident Investigator Lauren Grimm did a fantastic job as IIC on this. It covered just a tremendous amount of topics, a couple of which we will talk about today. And then we're going to get into Husky R13 to API. So prior trust R4 to API, prior trust R14 to IADC, and Husky R13 to API. So, a little background on this. January 22nd, 2018, a blowout and rig fire occurred at a prior trust gas well located in Pittsburgh County, Oklahoma. The fire fatally injured 5 workers who were inside the driller's cabin on the rig floor. The cause of the blowout and fire was the failure of both the primary barrier and the secondary barrier, which were intended to be in place to prevent a blowout. Now, for those of you that don't know, the primary barrier is the hydrostatic pressure produced by drilling mud, and the secondary barrier is the human detection of influx, and then the activation of the blowout preventer. And of course, in addition to the fatally injured workers, I mean, there was major damage to the drill rig itself. As a result of this, the CSB issued several recommendations. We're going to talk about R4 to the American Petroleum Institute, and then R14 to the International Association of Drilling Contractors. R4 to the American Petroleum Institute was to develop a recommended practice on alarm management specifically for the drilling industry. And we wanted it to be based on the International Society of Automation's 18.2 guidance, which is the management of alarm systems for process industries. The recommended practice is supposed to address the unique dynamic environment of the drilling industry and provide guidance on implementing a state-based alarm system for different operating modes, such as drilling, circulating, tripping, etc. We also asked that they include the International Association of Drilling Contractors in the development of this recommended practice. Then, concurrently, we issued R14 to the International Association of Drilling Contractors, which was to participate in the development of that RP that was recommended in R4. Next slide, please. Okay, so let's talk about the implementation of R4. So API, they set up the committee to discuss the recommendation, and the IADC is a participant on that committee. Based on discussions that they had in the committee, it was determined that maybe a better approach, instead of API developing an RP, but IADC, they had a drilling control system alarm management guideline that was already out. They thought maybe the best thing to do was to update those guidelines. And in fact, that is what they did. They developed a product called IADC Drilling Control Systems Alarm Management Guidelines, Volume 2. And when we went through the product, it addressed all the requirements of the recommendation. Now, for those of you who don't know, in the Office of Recommendations, we have various statuses. And for closed acceptable alternative action, that can also occur when a recommendation is successfully implemented by an entity other than the recommendation recipient. So in this case, the recommendation went to API, but IADC, they actually implemented it on their behalf. As a result, we recommended to the board that they close this recommendation acceptable alternative action, and that is in fact what they did. Next slide, please. So now we're going to talk about, that there was a recommendation that was issued to IADC. We asked for them to just participate in the development of the RP. And in this case, like I say, they actually came out and they implemented the requirements of the recommendation. Based on the fact that they far exceeded the participation requirement of that recommendation, they get one of our most esteemed statuses, which is closed exceeded recommended action. We immediately proposed that to the board. They concurred, and that is what they did. They closed this recommendation, exceeded recommended action. So in this case, we get to say fantastic job, API, as this is a group in the committee, and absolutely amazing and fantastic job to IADC in a product that addressed our recommendation. Next slide. Okay, now we're going to talk about the Husky Superior explosion and fire. On the morning of April 26, 2018, the primary and sponge absorber of the Husky Energy Superior refinery exploded during a planned shutdown of the facility's fluidized catalytic cracking unit, or FCC unit. Debris from the explosion struck an asphalt storage tank approximately 200 feet away. Asphalt leaked from the damaged tank and over the containment wall, spreading into the FCC and crude unit operating areas before eventually catching fire. Husky Superior Refinery reported that 39,000 pounds of flammable hydrocarbon vapor mixture, as well as approximately 17,000 barrels of asphalt, were released during the incident. 36 refinery and contract workers received medical treatment as a result of the incident, and it was reported that the explosion shook buildings up to a mile away. The plume from the burning asphalt was visible from neighboring communities, and an evacuation order was issued by the county officials to protect the public from the smoke plume and as a precaution for fear that the incident would escalate. As a result of the incident, the facility was completely destroyed, and the incident resulted in $550 million of on-site and $110,000 of off-site property damage. The incident was recorded as having the 33rd largest adjusted property damage loss in the hydrocarbon extraction, transport, and processing industry since 1974. So as a result of this, CSB issued several recommendations. One of those was R13 to the American Petroleum Institute, and we asked them, using API's process to determine the appropriate safety product, to develop a publicly available technical publication for the safe operation of fluidized catalytic cracking units. Documentation should be available to both new and existing units and include the following topics at a minimum. We wanted a description of the typical FCC unit hazards, including air leaks into hydrocarbon systems or hydrocarbon leaks into air systems that could form a flammable mixture during transient operations. We wanted safeguards to control FCC unit hazards. We wanted monitoring for process safety during FCC unit transient operations. We wanted emergency operating procedures for FCC specific scenarios. We wanted PHA guidance for key FCC specific scenarios, guidance for process safety assessments of FCC units, and we wanted to incorporate the lessons learned from this investigation, as well as the CSB's ExxonMobil Tolerance Refinery electrostatic precipitator explosion investigation. And we wanted those references in the document's bibliography. So we asked for a lot of things. Next slide, please. As far as implementation, so again, API formed their committee. They wanted to discuss the recommendation. And several of the members in AFPI are also in the American Fuel and Petrochemical Manufacturers Trade Association, AFPM. What you'll find is sometimes these groups come and talk to us, and sometimes they just handle this amongst themselves. Like the prior trust, they just sort of did what they were going to do. In this particular case, the AFPM came to us and gave us a presentation on what their intentions were. And what they did is they developed publicly available information and put on several regional workshops addressing the requirements of R13. And I mean, and there's a lot of requirements there for the safe operation of FCC units. Again, Adam Henson, who just presented, he went out and attended one of those regional workshops and basically verified that everything in that recommendation, or all the requirements of that recommendation, were in fact addressed by AFPM, in this case on behalf of API. Again, because the closed acceptable alternative action status can be done when the recommendation is successfully implemented by an entity other than the recommendation recipient. We propose the board that they close this recommendation, acceptable alternative action. They concurred, and that is what they did. Next slide, please. So why is this? Why did we talk about this? The stakeholder engagement. Stakeholder engagement in our advocacy program are the secret formula, I'll say, secret formula, to implementation of recommendations. In this particular case, Adam addressed API, NFPA, ICC, NBBI, and ISA. API, since we've been an agency, we've issued them 56 recommendations. The first one was way back when we were first created, and that's back in September of 2000. For NFPA, we've issued them 22, ICC has been issued 10, NBBI has been issued 3, and ISA, our newest recipient of recommendations as far as a standard developing organization goes, we've issued them 1. We say welcome to the team of our partnership and safety. So welcome to the team ISA. But if you look, so API, almost, well, a little over 5% of the recommendations we've issued have been to API. They are our primary stakeholder partner in chemical safety. Right now, there's 16 of those 56 open. NFPA, we issued them 22. They have 2 that are left open. ICC, we've issued them 10. They've got 3 that are open. NBBI, we've issued them 3 in the lifetime of our agency. There's 1 open. And ISA, again, we've issued them 1. There's 1 open. But as a result of that stakeholder engagement that Adam Henson does so well, I mean, all of these have a path to an acceptable closure, which is what we want. That's going to be a victory for safety. So in conclusion, I'll say this. Every chemical incident that the CSB investigates is absolutely a tragedy. However, it also offers an amazing opportunity through our investigation, the recommendations, and lessons to industry to drive chemical safety excellence, to protect communities, workers, and the environment. And that opportunity is why we do what we do. And with that, I will pass it back to Executive Director Kleist.
Well, thank you, Chuck and Adam, for that presentation. As Chuck mentioned, the recommendations program at the CSB is often an underappreciated critical element of our mission. The first step in a very long journey is the development of the report and the adoption of that report and associated recommendations by the board. But it takes a considerable amount of effort to advance those recommendations and to advance the learning from our investigation work to the industry and our key stakeholders. And that's done through board members, the recommendations team, as well as investigators who go out and meet with these various groups to, again, share the learning and to advocate for adoption of these recommendations by the groups that have the power to do so. So again, it's a long journey that takes quite a bit of effort, but that's why we're here and that's why we continue to do the fine work that we do. So thank you, Chuck and Adam, and all those that participate in the advocacy and outreach program. The final item on our agenda for our presentation this afternoon would be the Optima Bell accidental release video. Recently produced, and we are ready to share this with the community this afternoon. Would like to recognize Hillary Cohen and Shauna Lawhorn for the work that they do in producing these videos, which are not only recognized and used domestically, but also used extensively by our international audiences, again, to advance safety. So Brian, when you're ready, if you could show the Optima Bell video, please.
December 8th, 2020. The Optima Bell Chemical Facility in Bell, West Virginia. One employee was killed and 2 others were evaluated for respiratory irritation when a pressure vessel exploded, causing a fire and toxic chemical release.
Our report identifies several factors that led to this tragedy. In particular, we have found that gaps in existing regulations do not adequately protect against hazards presented by reactive chemicals. This long-standing safety gap must be addressed.
Optima Bell is a toll manufacturer, or a company contracted to provide chemical processing services, typically using its own equipment. On the day of the incident, Optima Bell was working on behalf of Clearon Corporation to conduct a batch tolling operation. The tolling operation involved Optima Bell dehydrating a chemical called CDB56. CDB56 is a white powder that is used as a source of chlorine for cleaning and sanitizing products. When CDB56 is exposed to high heat, it can decompose and release chlorine and other toxic substances. The batch operation was intended to dehydrate CDB56 to transform it into a different compound that Clearon calls CDB63. CDB63 is a white granular material that is used for water chlorination in swimming pools, as well as in detergents and bleaching agents. Like CDB56, it can also decompose and release toxic chlorine when heated. For the batch dehydration process, Optima Bell planned to use a type of pressure vessel called a rotary double cone dryer. Clearon, however, had never before used this particular kind of dryer for dehydrating CDB56. Therefore, Optima Bell developed a new procedure for the dehydration operation. Their plan was to heat the compound by applying steam to the jacket of the rotary double cone dryer, while the dryer rotated to tumble the contents inside. And equipment would be used to create vacuum conditions in the dryer to help remove any gases produced, such as water vapor. Optima Bell, however, did not realize that heating CDB56 inside the dryer could cause the compound to decompose. On the morning of December 8, 2020, Optima Bell employees started the first of 4 planned batch operations to dehydrate the CDB56. They applied heat to the dryer, and workers from both Optima Bell and Clearon monitored the progress. But by late afternoon, workers observed some operational problems. They stopped the dryer to troubleshoot. About an hour later, they restarted the dryer's rotation, and steam was reintroduced to the dryer's jacket. But problems persisted. A sample of material taken from the dryer around 7:30 p.m. showed that moisture levels of the compound were not decreasing as expected. And now the white material contained dark specks. After Optima Bell texted Clearon about the issue, workers stopped the flow of steam to the dryer's jacket and stopped the rotation of the dryer to investigate the cause. Both Optima Bell and Clearon workers suspected that the dark specks could have been due to corrosion of 2 stainless steel valves on the dryer, which was otherwise constructed of a corrosion-resistant material. Later, an Optima Bell employee told the CSB that when looking inside the dryer to investigate the suspected corrosion, the compound inside appeared lumpy with a yellowish tint and smelled like chlorine. While the workers were troubleshooting, the internal temperature of the dryer continued slowly increasing, even though no steam was flowing into the dryer's jacket. That is because, unknown to the workers, The earlier heating of the dryer had likely caused the compound inside to start decomposing, and a dangerous runaway chemical reaction was now underway. Workers continued troubleshooting, and by 9:30 p.m., Optima Bell and Clearon agreed to stop the batch operation for the night and continue to investigate the cause of the black specks the following day. But at approximately 9:40 p.m., the decomposition reaction underway in the dryer increased rapidly, causing the temperature and pressure inside the dryer to spike. Within minutes, the dryer catastrophically exploded. Metal debris from the explosion struck a nearby methanol pipe, causing it to rupture. The released methanol ignited, and a fire broke out. Other metal fragments from the dryer were found up to a half-mile from the site. One Optima Bell employee was killed. 2 others were evaluated for respiratory irritation, and 1 member of the public reported an injury related to the explosion. The CSB launched an investigation and found 5 safety issues contributed to the severity of the incident. They are process knowledge management, thermal hazard assessment, equipment selection and design, tolling of hazardous materials, and regulatory coverage of reactive hazards. The first safety issue is process knowledge management. As part of their tolling agreement, Clearon provided a technology package to assist Optima Bell in the development of the design and operating procedures for the dehydration process. But the CSB found that Clearon's technology package was inadequate and lacked critical known information on the decomposition of CDB56. For example, Clearon's own safety data sheet for CDB56, which was included in the package, listed its decomposition temperature as between 240 and 250 degrees Celsius. But the CSB found that in the 1970s and 80s, a Clearon predecessor had conducted testing that showed CDB56 could decompose at much lower temperatures. These findings were documented in a report that Clearon had in its possession, but did not provide to Optima Bell as part of the technology package. And post-incident testing of the material confirmed that CDB56 could begin a runaway decomposition at just 81 degrees Celsius. Because Optima Bell was not provided this crucial information, the company believed the dryer temperatures would be low enough to avoid a runaway decomposition reaction by design.
Accurate process and product knowledge is essential for the safe operation of chemical processes. There can be little expectation of safety if the companies operating a process don't fully understand the chemicals and their associated hazards. Our investigation found that Optima Bell lacked crucial information on the decomposition of CDB56. Accordingly, we found gaps in the ways that Clearon maintained and managed its key process knowledge, particularly in the way that it managed that knowledge with respect to its toller, Optima Bell.
As a result, the CSB made a recommendation to Clearon to develop and implement a comprehensive process knowledge management program, or evaluate and revise existing process safety management procedures to ensure consistency with industry guidance publications. And the agency recommended that Clearon update its CDB56 safety data sheet to more accurately represent the known hazards of the compound. The second safety issue involved in the incident is thermal hazard assessment. The CSB found that both Optima Bell and Clearon failed to effectively assess the hazards of CDB56 and the batch operation. For example, both companies failed to identify the temperature at which the material could decompose, failed to conduct adequate literature searches for public or internal safety data, and failed to use readily available reactive hazard screening methods to assess the reactivity of the material. Had Clearon or Optima Bell performed a thorough thermal hazard assessment, the parties could have understood the hazards of the dehydration operation, and the explosion could have been prevented.
There are many publicly available tools that companies can use to screen new or existing chemicals for reactivity hazards. Some of them are simple screening tools that can be used to quickly determine if further research is required. Others, like differential scanning or accelerating rate calorimetry, provide detailed quantitative lab results that can be used to design a safe process. Using these thermal and reactive hazard assessment tools and developing processes accordingly can prevent tragic accidents like the Optima Bell explosion.
In its report, the CSB recommended that Optima Bell develop and implement a written thermal and reactive hazards evaluation and management program. The third safety issue that contributed to the incident at Optima Bell is equipment selection and process design. Optima Bell used existing production equipment for the batch tolling operation, but the CSB learned the equipment was not designed, sized, or re-engineered for the process. As a result, the dryer was unable to quickly cool the contents if they became overheated, nor was it able to relieve the pressure generated during a decomposition. And on the day of the incident, Clearon and Optima Bell essentially conducted an experiment on a new method to dehydrate CDB56 at full production scale. This was done without first experimenting at a laboratory or on a smaller scale, which could have alerted the company of hazards and led to changes in the process. Instead, the end result of this decision was a catastrophic explosion.
We found that Optima Bell's pressure relief system for the dryer was not designed or evaluated to relieve the pressure produced by the decomposition of CDB56. When using existing equipment for a new process, companies need to ensure that the equipment design is appropriate for the proposed new process. Had pilot or lab scale studies been conducted, Optima Bell and Clearon likely would have gained additional data on CDB56 and improved process knowledge. This might have led to changes in the equipment or process design, potentially preventing the explosion.
The fourth safety issue found by the CSB is the tolling of hazardous materials. Companies often augment in-house production by outsourcing chemical processes and other operations. These agreements are called tolling contracts. Clearon established a tolling contract with Richmond Chemical, a tolling broker, who in turn contracted with Optima Bell. The Center for Chemical Process Safety, an industry organization, provides guidance for safe and effective tolling arrangements. But the CSB found that neither Clearon nor Optima Bell adequately followed that guidance. Their deficiencies included inadequate exchange of process knowledge between the tolling parties, inadequate mutual involvement in the process hazard analysis, inadequate understanding, characterization, and analysis of the hazards of CDB56 and the dehydration operation, and no evaluation of the technology change from the type of dryer typically used for the process to the rotary dryer available at Optima Bell.
Outsourcing the production of a hazardous material does not outsource the responsibility for process safety. Effective process safety and the prevention of a catastrophic incident are responsibilities that should be shared by all parties involved in a tolling operation.
As a result, the CSB recommended that both Optima Bell and Clearon develop and implement a written program for tolling process design and equipment selection using available industry guidance. Finally, the fifth safety issue that contributed to the incident at Optima Bell is regulatory coverage of reactive hazards. CDB56 is a reactive chemical that can undergo a self-accelerating decomposition when heated. At Optima Bell, the decomposition led to a catastrophic explosion, fire, toxic emissions, and the death of an employee. Yet this chemical, and many such reactive chemicals, are not regulated under OSHA's Process Safety Management Standard or the EPA's Risk Management Program rule. Had CDB56 been covered under those regulations, Optima Bell would have been required to implement risk mitigation and management systems that could have prevented this incident.
The CSB has a long history of investigating reactive chemical incidents. including producing a 2002 study in which the CSB called on OSHA and the EPA to expand their standards to address reactive chemicals and their hazards. To date, however, neither agency has acted on our recommendations.
Therefore, in its final report, the CSB reissued its 2002 recommendation to OSHA to amend the Process Safety Management Standard to achieve more comprehensive control of reactive hazards that could have catastrophic consequences. And the agency reiterated its 2002 recommendation to the EPA to revise the accidental release prevention requirements to explicitly cover catastrophic reactive hazards that have the potential to seriously impact the public, including those resulting from self-reactive chemicals and combinations of chemicals and process-specific conditions.
The CSB believes OSHA and the EPA must strengthen their regulations on reactive chemicals. Regulations addressing reactive hazards will help keep similar incidents from occurring, prevent injuries, deaths, and protect those who live in nearby communities. The time is now for those agencies to act. Thank you for watching this CSB safety video.
For more information, please visit csb.gov.
Well, Brian, thank you for showing that video. Before I pass this presentation back to Chairperson Owens, I do think it's important to emphasize that whether an operator is covered by the process safety management regulation or not, these reports that we covered today, the Honeywell, TSUSA, and the Optimabel investigation video, really does underscore the importance of an operator having a strong safety management program that identifies and controls the hazards associated with their operation to ensure that process safety issues are identified and properly addressed. And we hope that these reports help to accomplish that for companies engaged in petroleum refining operations, petrochemical manufacturing, and chemical manufacturing operations. With that, this concludes the presentations for the Office of Investigations and Recommendations, and I pass the presentation back to Chairperson Owens.
Well, thank you, Steve, and thanks to everybody who gave those terrific presentations. We have a very strong recommendations investigation group at the agency, as well as all the other people at the agency who provide support to our investigators and recommendation specialists in the course of these investigations that we conduct here. So we all work together very closely as a team, and each and every person at the CSB is responsible for the work that we put out and played a major role in all the events that we discussed here today. I'm going to make an executive decision. I mentioned earlier that we had produced a short video recapping some of our recent incidents. It's only about 5 or 6 minutes long, but we're getting pretty close to the end of our 2-hour time slot here. So I'm going to urge people instead, you can go see the video on your own. It's not that long. It's a good summary of some of the recent investigations that we concluded and issued reports on as part of the backlog. And when we were cleaning that up, it's available on our, not only on the CSB website, but also on our YouTube page, as is the Optima video. I will make a commercial advertisement for our YouTube page. We have 379,000 subscribers to the page at the moment. We're pushing upwards close to 380. So if you haven't yet signed up as a subscriber to our page, please do that. Help us get to 380 at least. And also tell your friends about it, because it's got a lot of great information there. The Optima Bell video that you just saw has just been out little over a month, as I had indicated in my comments, and it's already received 288,000 views in the short time that it's been out. The short recap video, which we're going to pass on and not see today. But if you go look at that, it won't take a lot of time. As I said, it's only been up less than a couple of days, and it's already got more than 55,000 views on our YouTube site. So take a look at that if you get an opportunity to do so. I do want to leave a little time, as I said, for public comment. Just outline again kind of the rules of the process here. In a minute, Brian will open it up for comments. But if you have a comment, please use the icon, and so you can raise your hand. It can be recognized by Brian. State your name and your organization if you're with an organization, if you don't mind doing that. And also, please keep your comments to 3 minutes in the interest of time, especially since we are getting close to the 2-hour limit. I will give the caveat that I always give, is that generally we try not to respond directly to comments and especially to questions, but if there's something very specific with regard to one of the incidents that we discussed here today, one of the investigations or other matters that we discussed here today, we can provide a quick answer to it. We always try to do that as well. And last but not least, if you have a comment we either don't get to, you don't want to make it during the course of this, say, you can submit it to us online. Again, that's an email address. It's public, public@csb.gov. So with Brian, we've got roughly 10 minutes or so left in the meeting. Let's see if anybody has a comment. So.
I'll keep an eye on the clock, and I'll keep an eye on the participants list. Again, anyone that wants to be acknowledged, hit the raise your hand button. I can ask you to unmute and give you an opportunity to leave a comment.
I know this was a long meeting. We covered off a lot of stuff, so you can see why we wanted to go ahead and get this done in June, because we got a lot more things we're working on that will, assuming we have a follow-up meeting later before the end of the fiscal year, we'll be covering other things as well then. So, all right, Brian, did we lull them into submission here? So,
You may have answered everything with the initial meeting.
all right, well, hearing none, we'll then proceed to close the meeting. We'll turn it over to Sylvia, and then Sylvia Johnson, and then Kathy Sandoval for their closing remarks, and then I'll take us home. So Sylvia, turn it to you.
Thank you, Steve, and thank you all for joining our meeting today. As you've heard from the wonderful presentations from the CSB staff, not only have we closed investigations, but we continue to work with our stakeholders on recommendations to make the work that we do even more meaningful and more impactful. And so I can't overstate how important our stakeholders are to us, because we can't do this work and make it meaningful and impactful without the assistance and continued engagement from our stakeholders, whether you are on the call as an observer, or if you are one of our stakeholders who actually receives our recommendations and execute those recommendations. That is important to the work of the CSB. And so this team continues to produce great work, and the way that we keep producing that great work is to keep engaging our stakeholders and making sure that what we recommend actually gets implemented. And by implementing the recommendations that we make from these pretty disastrous events, we can have an impact on workers, communities, and the environment. And so with that, I'll turn it over to you, Kathy.
Thank you. Thank you very much, Dr. Johnson. And thanks to the CSB's great staff for your investigations and work. Very commendable. As you can see, we've been very busy with closing a number of investigations, while we simultaneously have several investigations that are ongoing. So as you can see from our presentations, the CSB's work, as indicated by the BioLab presentation, highlights the hazards of chemical storage and warehousing, as well as chemical manufacturing and use. And so each of these types of sectors really needs to be looking at a variety of the issues that we have identified, including reactive hazards, the potential for chemical decomposition, as well as knowledge management, process safety, and a variety of other issues. So the CSB's work and its public knowledge management assists operators, standard setting organizations, communities, and regulators. The CSB's work is implemented through law, through standards set largely by private sector organizations, by communities and non-governmental organizations, and by people across the country, including workers, managers, boards of directors, and everyone involved at various community organizational levels and living in communities near these hazards. We saw video where parts of factories are sometimes found 1.5 miles or more from the site, and these chemical plumes can also reach a tremendous radius and affect tens of thousands of people. So the CSB's work is really important and can really assist us in creating a safer nation that is able to carry out this vital sector of the economy in a way which is safer for all communities. So thanks to each of you and the critical role that you play in ensuring chemical safety and protecting the public, workers, and the environment. Thank you. Steve.
Well, thank you, Kathy, and thanks, Sylvia, for those great closing remarks. Appreciate everyone's participation in this meeting. I'll just add very quickly, follow up to both Sylvia and Kathy's comments and reiterate, we are a non-regulatory agency. We can't make anybody do anything. We, as it was said at the outset of this meeting, we don't issue fines. We don't try to punish people or anything like that. Instead, we do work collaboratively with the facilities and the companies who are the subjects of our investigation, as well as with all the interested parties that may be involved in an incident. And then our recommendations, we do make them not only to the companies themselves, and every now and then to a labor association as well that may be affiliated with the entity involved, but also to a variety of other entities, including the standard setting organizations that you heard about during the course of this meeting. We couldn't do it without the cooperation and collaboration of everybody involved during the course of the investigation. And when we make recommendations, we try to make sure that they are implementable. It doesn't do anybody any good for us to come up with a recommendation that nobody can put into effect. And so, again, we appreciate everyone who has worked so closely with the CSB on the investigations that we discussed here today, as well as the ones that we're currently involved in, and then have helped make work practices at so many of the facilities that we have investigated over the years safer, and make those safer places to work. So with that, I will bring it to an end. Brian, I'll turn it back over to you. And again, just as a reminder, if we do decide to have another meeting, determine that there's a need for one, we will go through our usual process of sending out an email notice, but we're also posted on the website, as well as put it in the Federal Register as we're required to do by law. So I thank you all again for being here. And Brian, over to you.
Steve, thank you. And I think that concludes today's business meeting. This meeting is recorded and will be available for viewing. Thank you for everyone.